All right, we are going to try to demonstrate this making a scatter plot by hand, fitting a line to it by hand, and then coming up with the equation for that line of best fit. Okay. So I've grabbed a little bit of data here, and I have a graph set up. I need to make some choices on my graph. I look here, and I see that my numbers go in this column from 0 to 50, and those are my inputs. It makes sense to talk about time jogging, calories burned. The independent variable is the time jogging. Calories I burn depend on how much time I spent jogging. So my jogging time will go down here. The time on this one will be about calories. I think those labels are probably going to get in the way of some things that I want to do here, but I'll shift that up that way and time off this direction. So this needs to go from 0 to 50. I should figure out how many squares I have here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If I went by tens, I'd run out right there at about 50. So 10, 20, 30, 40, or 10 for every 2. So I'll go 10, 20, 30, 40, 50, like that. That should work. I'll mark those so I can keep that straight. Those numbers are going to be pretty nice for me in this one. My range, in this case, I've got to go as low as 0 and as high as 604. I counted my spaces here. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30 that way. So 604 divided by 30 is about 20. If I do 600 divided by, what did I say? I had 30 of them going that way. 30 is definitely 20, so if I went up, every line was about 20, so I won't mark them all. 20, 40, 60, 80. We'll call that one about 100. 20, 40, 60, 80. Right there is 200. 20, 40, 60, 80. Right there is 300. 60, 80. There's my 400. 40, 60, 80. There is 500, and then the top of the graph would be 600. That should give me pretty close here. So let me put my points on. I've got a point at 0, 0. That one's easy. One at 10, 115. So again, that was 100. This was 120. So it's up pretty close to that. 20, 233. There's 20 to 20 to 40 would be right there. A little bit more than halfway up there, but that would probably be close enough. 30, 367. So here's 300, 20, 40, 60, 80, closer to the bottom end of that, somewhere, maybe a little higher than that. 40, 492. That's very nearly 500. 492, probably right around there. And 50, 604 would be just barely above the top of this. They look like a nice straight line. It looks like it would be a strong relationship here. So I'm going to take, and I'd normally be doing this with a ruler if I was on a piece of paper. I'm going to draw what I think is a line that looks like it captures what's going on there. That looks pretty good. Okay, now here comes the important part. I need to look through here and try to find and identify some points that look like I can see exactly where the points are on them. Okay, so I'm going to grab my green pen to do that. It looks to me like my graph probably went right through a point down here. I want to find points that are not too terribly close to each other. So I am going to use that point. And then I'm going to look up on the other end of my graph somewhere. And I certainly could use this top point, but this also looks like it goes right through a grid mark. Okay. And so this one was my first point at 10, 115. So I'm going to write that point down. And then this one up here is at 35, 420. So I'm going to use those 2 points to write the equation of my line, and I'll transfer those down here. I've got 10, 115. Okay. And a point at 35. My whiteboard's lagging a little bit. Okay, so I have those points. First thing I need to do if I'm writing the equation of a line is to find the slope. Slope of that line will be, let's see, that's 35, 420. So I need the rise, which is the change in y's, the 420 minus the 115, divided by 35 minus 10. Okay, so that's how far up do I go, divided by how far over I go. 420 minus 415 sounds like about 305 over 25, which I could go to a decimal. That's a fairly straightforward decimal when I divide by 25. So I'm going to do, get out my calculator, do 305 divided by 25. That's a 12.2. That's my slope. And then if I use my point slope form of the equation, which is y minus the y coordinate equals the slope times x minus x coordinate of a point, I can put my 12.2 in here. And I'll grab this point at 10, 115, and this, even just like that, works as a model for this information. Probably easier to move that 115 over. And I'm going to write this as a 12.2 times x minus 10. I'm going to do that and be consistent with what I do. And then I'm adding the 115 to both sides. Okay. So here where x was the time, right, what I put on the x-axis was the time, and my outputs are calories. So this gives me an opportunity to use this equation to make some predictions. So I could answer questions like, how many calories are burned running for, say, 70 minutes, since my time here is measured in minutes. And all that says to do is take this equation and put a 70 in for x. So y equals 12.2 times 70 minus 10 plus 115. That's a 12.2 times 60 plus 115. 12.2 times 60, according to my calculator, is 732 plus 115. Add 115 on there, we get 847 calories that are burned running for 70 minutes. Okay. Another type of question that I could ask is something like, how long do I have to run to burn Let's go way off the chart here and say 1,500 calories. Okay. It's a lot of calories to burn from running, but see if we can figure that out. So the 1,500 this time is calories. Calories was my y. So the equation I set up is I replace the y with 1,500. That's equal to 12.2 times x minus 10 plus 115. So I could start by subtracting 115 from both sides. And I would get, this is what, 1,385. I'll do distributive property over here. Multiply that 12.2 through, so that gives me a 12.2x minus 122. So I now add the 122 on both sides. If I do that, then now I'm at, what, 7, and carry a 1, 1507 equals 12.2x. And if I then just divide both sides by 12.2, I will get x equals, and we can get my calculator out again, 1507 divided by 12.2, and I get 123.5. Okay, so I'm going to have to run a little over 2 hours, right? 120 minutes is 2 hours. 2 hours and 3 minutes and 30 seconds. Right. 2 hours, 3 minutes, 30 seconds, because that's half a minute, is about how long I'm going to have to run to burn 1,500 calories. Okay. So that's an example of how to scatterplot. So there we've got our scatter plot of the information, making decisions about independent and dependent variable, marking the graph that we have accordingly so we get a nice big picture of this graph, plotting the points, putting down a line that looks like it fits along with what's going on with the data, grabbing a couple of points off there that we know are good values on those points. We want to make sure we don't pick some that are like right next to each other. That tends to throw things off a little bit. Finding the slope, putting it into the equation to get a model, and then using the model to solve some problems.